Hello boys and girls, this is Professor Nelson from Electronics. Today we will talk about a very important component in electronics, the Zener diode. Although this component is not as striking as other components, such as the transistor, the triode, the SCR, and other components, it is widely used in electronic boards, and you will find them everywhere, especially in switching power supplies. They are used as a reference or as a power source for the switching integrated circuit or high-frequency oscillator. This is the symbol that Zener diodes have. We have three different symbols, of which two are the most common. These two here, as you can see, look very similar to that of a common rectifier diode, with the difference that you can see that at the end they have that differentiation. So any of these symbols are valid. The latter is used mostly in simulators, and as in the case of rectifier diodes, it has an anode and a cathode. And like a normal rectifier diode, these diodes can work normally in direct current. That means that when you put positive on the anode and negative on the cathode, this Zener diode will work in the same way as a standard rectifier diode. It will conduct and behave like a closed switch. However, if you put negative on the anode and positive on the cathode, it has a very important or interesting property, which is that the diode will conduct in reverse as long as the voltage between the ends exceeds a threshold or voltage limit, which is called Zener voltage. This Zener voltage or threshold voltage that allows the diode to conduct in reverse is listed in the datasheets, and depending on the code, you will have Zener diodes that can conduct in reverse at 2 volts, 3 volts, 5 volts, 12 volts, or higher voltage. That is to say, there is a variety of Zener diodes with different voltages, in this case in reverse or Zener voltage. Something very important in the case of Zeners. When you buy a Zener diode, it normally indicates the Zener voltage or reverse voltage and the power of this. The current is not indicated, but rather how much power it will dissipate and the Zener voltage you need. As I indicated, it is normally used as voltage references or directly as a power source for switching or low-consumption circuits. Well, let's look in detail at the rest of its characteristics. Very well, the presentation of the diodes is quite varied since you will find them in different packages. As it is, in packages similar to rectifier diodes with a black body and a white stripe, always indicating the white or black stripe the cathode, and the opposite side would be the anode. Then you will find it in black, or you will find it in orange, in this case a crystalline or crystal package, where the black band is the cathode and the opposite side would be the anode. In the case of SMDs, it would be the same. They will have a white band. But this package is the most interesting because it looks like an SMD-type transistor. However, you will find it in this case as a Zener diode. The important thing is to have the code of the integrated circuit. In this case of the Zener diode, look for the datasheet. It will indicate how the Zener diode is arranged and thus achieve the measurement with the multimeter. One way to measure a Zener diode would be with a multimeter. You can measure it directly because it will work normally in direct current no matter what casing it has. How much voltage drop does a diode have in direct current? If I put positive on this one and negative on top, here I will get 0.7 volts. If I feed it with a source here, but with the multimeter it is more than likely that it will show me I don't know, maybe 57 volts. That is 570 millivolts. It doesn't matter what casing, they will all show me a value between 0.5, 0.7. So it should not go over 0.7 volts, and it should not go below 0.4 volts in this case. But in order to make these measurements, we have to build a circuit. But don't forget that casings vary quite a bit. You can find them as these black Zener diodes, as well as you will find them in crystalline orange, which is the most common color you will find. And so the maximum power that I have managed to find has been 5 watts down, 360 milliwatts, 1 watt, half a watt, a quarter of a watt. Let's see if in the comments you tell me what has been the maximum power that you have managed to find in the electronic boards that you have repaired. Well, now let's see how I could measure in reverse. In direct current, it is measured normally, and the measurement has to be that of a diode. But in reverse, if I put positive here and negative here, and it turns out that the Zener diode is 7 volts. What happens if it is 7 volts? Well, the multimeter will not allow me to measure. If this were a 2-volt Zener, I could measure it in reverse. I measure, and if it were 2 volts, it would mark 2 volts, or 1.7, very close to 2 volts. But if it is 7 volts, 10 volts, 15 volts, or 24 volts, I will not be able to measure with the multimeter. What I have to do in this case is to put together a small circuit that is quite simple. Let's go with the circuit. This is the circuit that requires a DC power supply, and our Zener diode placed in reverse with respect to the source. Note that here I have positive and down here I have negative. 24 volts preferably, and if it is a little more better, since most of the Zener diodes on electronic boards tend to be less than that value. They tend to be 15 volts, 5 volts, 3.3 volts. In the switch power supplies, most are 15 volts, so having a 24-volt source will allow you to check if the Zener is fine. As I indicated in reverse, it cannot be measured with the tester. However, if you place a resistor in series, the resistor will limit the current that passes through the circuit and will protect the Zener diode. So a current will come through here and will pass through here. Remember that the Zener diode can conduct in reverse when the voltage between its ends is greater than what it needs to conduct. If this were a 12-volt Zener diode, a 12-volt Zener means that between its ends there has to be a voltage greater than that. By having a series resistance of 10 kilo ohms, the current will be in milliamps. Therefore, 12 volts would fall on the Zener, which would allow it to conduct in reverse. 12 volts will fall on the resistor since this is a series circuit. 12 and 12 gives us 24 volts, so it is distributed in this way. However, if you had a 5-volt Zener, here there would be 5 volts, and here there would be 19 volts. Now, to do the calculations and all that, we will see it later. Now, do not forget that with this circuit you can know what value your Zener diode is. Since sometimes it is very complicated to know the value of the Zener diode because the letters are very small or are already blurred. Therefore, when assembling this circuit and taking the multimeter to voltage, you can measure the voltage between the ends of the Zener diode, always taking negative as a reference and the red or positive of the tester at the cathode end of the Zener diode. And thus you can obtain the Zener voltage of that diode itself. It does not matter which Zener diode you place, you will always have a drop depending on the voltage. To do this, we are going to build the same circuit and test it with 2 Zener diodes and see the voltage of each one. Here I have 2, and we are going to check which one is which. The largest one, just in case, is 1 watt and the smallest one is half a watt. Well, here we have the circuit. We have positive exactly in the negative of the Zener diode, and the positive part is going to negative of the source. There you can see that I am using 24 volts, I use 24 volts and a 10K resistor to protect the Zener. I put it there, and it shows 4.8 volts. This means that it is a 4.7 volt Zener diode. If I turn the Zener around, that is to say that the Zener diode is in a direct way, the drop will be 0.7 volts. There we have 0.7. That means that it is working like a normal diode in direct, the negative to negative, and the positive to positive. Therefore, a Zener diode will always work in reverse. You will never find it in direct, since for that you would use a normal diode. Therefore, the Zener will always be in reverse. Now we are going to place the other Zener diode and see what voltage it is. Remember that the negative goes to positive and the positive goes to negative. There you have it. It's 10 volts. There you can see the negative of the diode and the resistance to positive. That way you will be able to find the value of your diode. If the code is blurry, just don't forget to put the 10K resistor or values between 4, 7, or 20K. Try not to make it less because it could heat up due to the power. And if the value of the resistor is too large, then the maintenance current will not be enough to activate the Zener diode. Very well. To finish now, we are going to measure these two diodes. We have this diode that is damaged that I removed from a board, and this one that is in good condition. Now in the one that is in good condition, positive to negative, and negative to positive. Well, it doesn't show anything. Remember that it has to be in diodes. And finally, negative to negative and positive to positive. There we have 0.7 volts. Now let's measure the damaged diode. 0 and inverse 0. Well, this way you can know if your diode is good or if it is bad. If it doesn't measure in reverse, it's not that it's wrong. It's just that the multimeter can't measure it. And that's why you have to put together the circuit seen above. Well, guys, if the video has been helpful to you, a like helps the channel a lot. I'm off. Until next time. Bye-bye.